Hello. In this video, we're going to be looking at geometric sequences. We're going to look at exactly what is a geometric sequence and how to find any term of a geometric sequence. So let's start off by looking at exactly what is a geometric sequence. And the easiest way for me to describe this is using an example. Okay, so if we have a list of numbers 4, let's say 4, 12, 36, 108, this is a geometric sequence, and here's why. A geometric sequence is a list in which each number is obtained by multiplying the same fixed number each time to get the next number. So in this case, to get to 12, I have to multiply by 3. If I do the same thing and multiply by 3 again, I get 36. If I do the same thing again and multiply by 3, I get 108. So a geometric sequence just keeps going in this pattern, the same fixed numbers multiplied each time to get the following number. We call this number the common ratio, and we use R for short. So let's write that down. The common ratio, which is R for short. Our first term, just like arithmetic sequences, our first term is called U1. So term, we use that letter term, U for term. Some people say A, some people say T. I use U. It just depends on which textbook you're looking in. Alright, so the term is U, and the first term is U sub 1. And any term, so the general term, any term at all, is called U sub n. So that n represents any term. So speaking of the n tells us the position of the term. So for example, if I'm looking for the 50th term, n is 50. If I'm looking for the 8th term, n is 8. So that's what n is. So now that we know all those wonderful letters and symbols and stuff, we can actually come up with the formula for finding any term in a geometric sequence. Okay, so I'm not going to just jump in and give you the formula to find any term of a geometric sequence. We're going to have to figure this out together. Alright, so let's put our sequence back up here. We had a sequence, it was 4, 12, 36, and 108. And we were going to just keep going with that sequence. Alright, so here is the question to you. How did we get our first term? Well, we didn't get our first term, it was just given to us. U1 is simply just U1. Alright, let me move this over a little bit. Alright, and here we go. U1 is simply just U1. But how did we get our second term? Well, in order to get our second term, we had to take U1 and multiply it by R. How did we get our third term? Well, we had to take our U1 and multiply it by R twice. And how about U4? Well, we took our U1 and we multiplied it by R, and now we're going to have to multiply it by R once more. Alright, so here's the thing. Here we have R to the first power. Here we have R to the second power. Here we have R to the third power. So U1 is always being multiplied by R to some power. So how do we figure out what the power is here? Well, when we're looking for the second term, the exponent of R is 1. When we're looking for the third term, the exponent of R is 2. When we're looking for the fourth term, the exponent of R is 3. If you notice, what's the relationship between the term, the n value, and the exponent of R? Well, the exponent of R is always 1 less than our n value. So that's actually the formula. We could keep going and say, well, un therefore is U1 R to the n minus 1. Alright, so that's the formula that we'll be using to find any term of a geometric sequence. You won't actually have to know how to figure out what that formula is ever again, but I just wanted to show it to you because it's pretty cool. Alright, so now that you know the formula to find any term of a geometric sequence, let's go ahead and find maybe, let's say, the 8th term of this sequence. So Actually, I want to go even bigger. Let's find the 20th term of this sequence. All right, so same example with 4, 12, 36, and 108. Find the 20th term. And again, that's of this sequence that we have written up here. All right, so finding the 20th term, we would go to u20 equals u1 to the r times r to the n minus 1. So u20 is u1, and u1 is 4. So 4 times r, which is, well, what is our common ratio? We're jumping each time by 3. So r is 3 to the 20 minus 1. All right, so when you're plugging into your calculator, please keep in mind that only the 3 here is raised to that power of 19. The 4 and the 3 cannot be multiplied first, so only that 3 is raised to that power. Once you've done this in your calculator, you should get something that looks like this, 4.649, and it just keeps going and going, and then you will see it E9. What does that mean? Well, our calculator is giving our answer in scientific notation, but it's not written the way that we should write it down, because we are not a calculator. So whenever we see that E9, it means times 10 to the whatever. So in this case, this is equal to 4.649 times 10 to the 9th. If you saw E7, it would be times 10 to the 7th. If you saw E negative 5, it would be times 10 to the negative 5, and so on and so forth. So whenever you see that E, don't just write down that E. Write it in the way that you should actually write it for scientific notation. All right, I just wanted to show you a couple more things, and then we'll be done with this video. Okay, so the two things I have left to show you, I decided to show you in one single example. All right, so we have a sequence here, and it looks a little weird, right? We have positive, negative, positive, negative. We have a fraction at the end. We have all kinds of weird stuff going on. All right, you may actually see what r is, but if you don't see what our common ratio r is, in any situation, there is a foolproof way that always works to figure out what r is. So remember the definition of our common ratio r. R is the number that you're multiplying by each time to get to the next number, which means that in order to figure out what that number is, you can simply take two consecutive terms and divide them by each other. So r is actually u2 over u1, which is actually going to be the same thing as u3 over u2 or u4 over u3. It actually doesn't matter which consecutive pair of terms, as long as you're taking the term afterwards and dividing it by the term before. So in this case, our r value is negative 60 over 120, which is actually negative 0.5. So if you test it out, you'll realize that yes, each time we're multiplying by negative a half, negative 0.5, to get the next term. It does make sense now that you can see it, hopefully. I think it makes sense. All right, so now that you know what r is, we're able to find something called the general term. Now remember, you may remember from arithmetic sequences that the general term formula is just a formula that gives you any term in the sequence. So this is the general, I call it the general term, because this tells you any term in any geometric sequence. But if you're being asked for the general term of a specific sequence, of this sequence, you want a formula that will work for this sequence. All right, so let's go ahead and figure out what that would be. Since it is general, un and n stay as un and n. But we do know the first term. The first term, let's put it off to the side, u1, the first term is 120, and we just figured out that r is negative 0.5. So now we can plug in our u1 as 120 and our negative 0.5 as r, and n minus 1 stays n minus 1 because it is general. And is this where it stops? Can we then multiply this by this? Absolutely not. We cannot multiply these two things because negative 0.5 is the only thing being raised to this power. So here is our final answer.